What is a stem and leaf plot? Good question. It is a way to visualize data to show the distribution. We group up the data and then we can see patterns in the data. The best way to show it is with an example. According to the CSIRO, changing rainfall provides evidence of climate change in Australia. Suppose that we count the number of rainy days each year for 9 years and find the following results. You can see in the first year there were 67 rainy days, in the second year there were 90 rainy days, and so on, for our 9 data points in the raw data. Let's now put that into a stem and leaf plot. The first thing we do is the headings, stem and leaf, and a vertical line between them. The stem shows the groups. These are all 2-digit numbers, so let's group them in tens. The smallest is in the 50s, so I'll start with a 5, and the largest is in the 90s, so I'll keep going 5, 6, 7, 8, 9. Even if there were nothing in the 80s, I would still put an 8 here. Okay, so now we can put each of these down in the leaf section. The first number is 67, so I go to my row for the 60s and put a 7. The next row is 90, so I go to my row for the 90s and put a 0. My next one is 54, so I go to my row for the 50s and put a 4. My next one is 69, so I go to the row for the 60s and put a 9. You can see that I now have 2 numbers in the 60s. This one represents a raw value of 67, and this one represents 69. And I keep going. 79, so I put a 9 here. 70, so I put a 0 here. 73, so I put a 3 here. 87, so I put a 7 here. And 83, so I put a 3 here. And that is a stem and leaf plot. It's useful for a lot of things. We can count how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes sense. We can see which was the most popular bin, the most popular group, which was in the 70s, and so on. Often we also put a scale. As we write scale, and then we write an example. 5, a line, and then 4 is 54. The reason we do that is because if the numbers were very small, like 6.7 and 5.4, we could show that instead of this number being the tens, it's the units and there's a dot next to it. Now we can turn it into an ordered stem and leaf plot. So notice that this, is in order, there's only one number. This says 7 and 9, that's already in order. These 3 leaves, 9, 0, 3, they're out of order. So we can rub it out and rewrite them in the correct order, 0, 3, 9. This says 7, 3, but to be in order, it should be 3, 7. So we can rub it out and put it in the correct order. Good. So now this is done. This is an ordered stem and leaf plot now. Let's describe the distribution of data. Well, you don't have to draw this curve, but it can help you, I suppose. If you imagine turning this on your side, you can see that the curve would look like this. This is the negative end up here, and this is the positive end down here, because this is the larger numbers. And you can see that it looks symmetric about the 70s. Even if it was really close to symmetric, but not quite, I would still call it symmetric. So this is a symmetric distribution. We can state the minimum and maximum values. Well, because it's in order, 54 is the minimum, 54 days of rain, and the maximum, the largest, is 90 days of rain. So that is the basics of how to draw a stem and leaf plot. Do you remember, to make your diagram neat, I like to put one number per each square. That makes it easier to compare the bins, the size of the groups. You can easily see that there is one more in the 70s than in the 60s, and so on. All right, I hope this has been helpful. I will see you next time. Bye, everyone.